This is our second multiplication rule, and this is called a conditional probability. Conditional probability. And look here, the probability of A and B equals the probability of A times the probability of B given A has already happened. And this is a vertical line. Okay? So you find the probability of A and B is probability of A times probability of B given A has already happened. Now this is for dependent events. Events, if they're not independent, then they're dependent. Now take this equation, probability of A and B equals the probability of A times the probability of B given A. Let me say a couple things. Probability of A and B is the same thing as the probability of B and A. Probability of B given A is not equal to the probability of A given B. Okay, come back to this equation, and I want you to solve for this conditional probability. The way you would do that is you would divide both sides by probability of A. So the probability of A intersect B divided by the probability of A equals this conditional probability of B given A. Now I'm going to swap sides. Probability of B given A is the probability of the intersection A intersect B over probability of A. If you're finding this conditional probability, you take the intersection, which is in the numerator, and you divide this probability of A in the denominator. That's already happened. So you are dividing by the probability of that. All right, let's find the probability of A given B. A given B will be the probability of A and B divided by what? The probability of which one? Is it A or B? It's going to be this one. The one that's already, the given, the one that's already happened. Okay, now that's all I've got on that page. I'm going to multiply, look here. To find the intersection, you multiply by a single probability times that conditional probability. You divide by the probability. Okay, read the problem, and you'll find out that box 1 has 5 red and 3 blue or black. What is it? Black. Box 2, so that's a total of 8 balls. And then box 2's got red and black, and that's got a total of 4. And box 3 has got 4 red, a total of 6. Now, how can you get, we're trying to find, if a box is selected at random and a ball is drawn, find the probability it will be red. Trying to find the probability it will be red. And there's 3 ways that can happen. It could be red and come from box 1, or, that's why I put a plus sign, red and box 2, or probability of red and box 3. Okay? And to find those intersections, okay, I think I'm going to draw a tree now, okay? And we got 3 things happening. So the probability, box 1, you got 3 boxes, that's going to be 1/3. The probability they choose box 2 is also 1/3. And the probability they choose box 3 is 1/3. Now, the probability it's red given what? Well, I'm up here on this branch. I'm on the box 1 branch, given it came from box 1. Well, what's the probability of red given box 1? Well, box 1 would be 5/8 because you got 5 red out of 8 balls. The probability it's red given it came from box 2. Box 2 has got 3 red balls and there's a total of 4. And then the probability of red given box 3 is what? Look at box 3. You got 4 red out of 6 balls. 4, 6. And just for notation purposes, if we were concerned about not red, this bottom branch, each one of these would have a bottom branch. And it would be, the notation would be the probability not red given box 3. And that would be 2 over 6 because these have got to sum to 1. All right, so I just wanted to show you that. Now I'm going to erase it to make sure I have plenty of room. All right, so let's find our answer. And I've there we go. I've really almost ran out of room here. So if I take this single probability of 1/3, and if I multiply that by the conditional probability, which is 5/8, that gives me this, R and B1. Then if I add to that, if I multiply 1/3, that single probability, times 3/4, that conditional probability, that gives me the probability of box 2 and red, plus 1/3 times 4, 6, that's this intersection here. And that will give me 5 over 24 plus 1/4 plus 2/9. I'm just multiplying my fractions. Yep, those 3's cancel. The common denominator would be 72. I'm not showing that work. Your final answer is 49 over 72. Now I've got another example, 2. So here we're trying to figure out the probability if the model is defective, and we've got model 1 and model 2. So I'm going to do a decision tree. Probability of model 1 is 0.8. They tell me that here. 80% of sales comes from model 1. And then how many would come from model 2? Probability of model 2 would be 0.2. And they tell me that. So the probability, it's a model 1. No. Probability of defective. Probability of defective given model 1 is what? Probability of defective is 10%. They tell me that. And the probability of defective given model 2 is, model 2 is 0.18. Trying to find the probability is defective. And there's 2 ways that can happen. Model 1 and defective, or model 2 and defective. So if you multiply 0.8 times 0.1 plus 0.2 times 0.18 times 0.18, that gives you 0.08 plus 0.036 with an answer of 0.116. And this 0.8 and 0.1 is the intersection of model 1 and defective. And the way you get that intersection, you multiply probability of model 1 times the conditional probability of defective given model 1.